I've heard of organic fish, I've heard of organic broccoli and fruits and vegetables and all these things. But what is organic chemistry? Come and I'll introduce you. Hey, welcome again, guys. Today we're talking about organic chemistry. Now, organic chemistry is really carbon chemistry. So you're studying carbon and its compounds, but there are a few exceptions. So the exceptions are the oxides of carbon, and the oxides of carbon are carbon monoxide, carbon dioxide, and carbonates. So anything which contains carbon except these three things, and you could probably talk about carbon nanotubes as well, and fullerenes as not being, graphite and diamond as not being organic as well, but mostly focused on these three oxides: carbon monoxide, carbon dioxide, and carbonates. So anything else which contains carbon is considered organic chemistry. Okay, so that's the first thing. All right, so organic chemistry is carbon chemistry. The next thing that we are talking about is that carbon is tetravalent. Carbon is tetravalent. This is such an interesting thing. If you have watched any of my previous videos, I would have used that term tetra before. But all this means is that carbon has 4 electrons in its outer shell. There you have it. As you can see there, it has 4 on its outer shell, 6 protons, 6 neutrons, and 4 valence electrons. So therefore we say it is tetravalent. Now, what's the point of saying it's tetravalent? If carbon is tetravalent, what that means is that it will not gain or lose electrons to become stable. It will always share electrons. So as a result of that, this affects carbon compounds. So carbon is tetravalent. Now, one of the things which is affected by carbon being tetravalent is that carbon forms multiple bonds. Carbon forms multiple bonds. And by multiple bonds, what we're really talking about is that carbon forms single bonds. As you can see here, it forms single bonds with carbon. It forms single bond with hydrogen here, and it forms single bond with oxygen over there. There are other elements, but I'm just showing you these 3 here. Carbon also forms double bonds. As you can see here, carbon forms a double bond with itself. It also forms a double bond with oxygen, as you can see in that second example, and a double bond with nitrogen right there. Now, carbon can also form triple bonds. So here you have a triple bond with carbon, carbon triple bond, and you have a carbon nitrogen triple bond there. Okay, so carbon can form multiple bonds, and this will lead to a multitude of different types of organic compounds. It's very vast, the number of organic compounds that can be formed as a result of this. Okay, so carbon can form multiple bonds. Now, because carbon can bond with itself, it forms these chains, just like your necklace. If you think about your necklace, what you have on, your chain that you have on, it's made up of these different links. And you could consider those different links carbon atoms. Because as you saw before, carbon can form single bonds with itself, double bonds, triple bonds. So it can join to itself to form these chains. And this joining of itself to form chains is what we call catenation. So when carbon forms chains, we call it catenation. There are other elements that form chains as well through the process of catenation, but carbon is by far the most popular element which forms these chains. Now, in this example, what you're seeing is that carbon is double bonded to another carbon, then single bonded to other carbons throughout. Now, these little parts up here is just to say that the chain continues. And I've omitted hydrogens and any other elements from this just to show you that the chain can be formed. I could have continued to draw as many carbons as possible, but it may take me forever to draw all the carbon atoms. So I just drawn a few here for you. So this is what we mean by chain formation. Okay, so you have your carbon bonding and forming a chain, just like that, just like the links on your chain. Okay, so that is our fourth thing about carbon chemistry. Now, another thing about carbon chemistry is that carbon forms these things called hydrocarbons. Carbon forms hydrocarbons. As you can see so far, everything is about carbon. So carbon forms hydrocarbons. But what do we mean by hydrocarbons? It's very simple. Hydrocarbons just simply mean that these compounds are made up of carbon and hydrogen only, just like in these two examples. As you can see in these two examples, you have carbon single bonded to carbons in this first example with hydrogens around it. You can see those hydrogens around it, right? And then in the second example, you have carbon double bonded to carbon with hydrogens around it as well. These are two different types of organic compounds, but the fact is both of these two compounds are made up of carbon and hydrogen only, so we call them hydrocarbons. Now the interesting thing is that carbon can bond to other elements. Not all organic species are going to be hydrocarbons. So you will find that carbon bonds to oxygen. You'll find that carbon bonds to nitrogen, very popular. You'll find that carbon bonds to sulfur. You'll find that carbon bonds to halogens, like chlorine. And you'll find that carbon bonds to things like phosphorus. So it's not only hydrocarbons that you will see in organic chemistry. You will see carbon bonding to all these other elements. Carbon even has some interactions with metals from time to time, but those are very complicated cases, and we're not going to be discussing those. But the fact is, organic chemistry is vast, and carbon bonds to a lot of different compounds. Okay, now because carbon bonds to so many different types of compounds, what we have to do, and many different organic compounds are formed from carbon, what we have to do is we have to group these different these carbon compounds. And when we group them, we place them in a thing called a homologous series. Okay, or we place them in a homologous series. All right, so the homologous series really, even though it sounds complicated, is just the different groups, or as I like to call it, the different classes of organic compounds. So you have things like alkanes, you have alkenes, you have alcohols, you have imines, you have amides, you have ethers, you have esters, you have a lot of other things. Okay, but this is just to say that you have many different organic compounds and we place them in different groups called homologous series. All right, so carbon also forms these things called tetrahedrons. Now, as you can see, we have mentioned this word tetra before, and tetra just means four, and hedron, you know, has to do with a three-dimensional shape. Okay, so therefore we're saying that carbon forms these four shaped or sided figures called tetrahedrons. All right, now the structure around that tetrahedron is of this nature. Now this is a 3D representation, so to speak, in a 2D format, because these lines have meaning in organic chemistry. So this line that you're seeing going towards this carbon is saying that this carbon is going into the board, or it's going behind, it's pointing behind the board. All right, this one is pointing in front, so it's sticking out at you. This one is in the plane of the board, and this one is in the plane of the board. So this is a tetrahedral representation of how carbon forms its structures. And this really has to do when carbon is single bonded to other carbons or single bonded to other elements. So there you have it, guys. Thank you for watching. This is just a brief introduction to organic chemistry. I hope you find it helpful, and you may leave a comment. Please feel free to like, share, and subscribe to my channel, G Squared Academy, where excellence is epitomized. See you next time.